Hello everyone and welcome to this video. In this video we will write a program where we will try to insert elements into a binary search tree. So let's start the program. First I'll write hash include stdio.h, then hash include malloc.h for the malloc function we will need for allocating the memory dynamically, and then int main. First let me write the basic syntax. Return 0. Here we will have to first create the structure for the tree, for the node, for the elements. Struct node, I'll give the name node, and then here the members will be, I like to say data, in data, then struct node. It's a self-referential structure, it references to itself. Struct node left, since a binary tree has left and right child, so left and star right. Now we have created the node. Here we will declare the tree struct inside the main function. We are not declaring it globally, we are declaring it locally inside the main function. Struct node star tree. At first tree will be null, it has no elements. Now we will first write the functions such as insert, INORDER, POSTORDER, display, all these functions, create node. We will first write this and then we will use them in the main. So the first function that I will write is struct node star create node. The first function is create node. This is the prototype of the function, the declaration. The sound is, so this is the prototype. Here the definition is struct node star create node. Since we'll be returning a pointer of struct node type, that's why we are giving a star here, and int I like to say num. Now in this function create node, first I'll create a variable, structure type variable, to store the newly created node. Struct node star, let's say temp equals to, we have to allocate memory dynamically. We will do it using the malloc function. We have to typecast also to node pointer malloc, and size of struct node. The size, how much we want to allocate, is the size of struct node. Now after this we will have to do temp data. In the temp data, since in structure we have already specified this data, then left and right, so in the data part we will store the num, and in the left part we will store null, and temp right part also we will store null. Now simply we will return the temp. Since this temp is of struct node pointer type, that's why our return type of this function was also like that. Then the next function I want to create is void insert. This function will be used to insert elements into the tree. First parameter will be the tree where we want to insert. This will be a double parameter here, since we will have to modify the pointer, that's why we will use double pointer. Next parameter is int. It will be an integer, the data which we want to insert. So let's define it here. Void insert struct node star, I like to say tree, then in num the data. So here in insert what we'll do is, first we'll create a temporary variable to traverse the tree. Struct node star temp, let it be null at first, then we'll check if star tree, and see here one thing, we are giving here star tree because this is a double pointer. So to access the value of tree, the pointer tree, we will have to use star tree. We have to use double pointer because we will modify this, we want to modify this variable, and since tree is a local variable, it's not a global variable, so we cannot directly modify it. So we will be sending the address of this pointer, and to receive the address of pointer we need double pointers. So if tree is null, which means there is no element in this tree, then we'll simply make it point to a new node, create node. We are right now using this function which we defined just now, where it takes a number element and then it creates the node and then it returns it. So we'll send the num in the insert function which we receive. Now in the else part, if the tree is not null, then what we'll have to do, we'll have to compare each element we want to insert with every node of the tree, and depending on whether the size is larger or smaller, we'll insert it in the right or left side. So first I'll make temp point to the tree, start tree. Now as I said, the start is required to access the value of the pointer. It's a double pointer. So temp equals to start tree. Now I will check, yes, I will use a while loop. Inside this while loop, this all will go. I'll say while 1. We'll actually break out of this loop using the break keyword. We will not use any kind of condition. We'll just create an infinite loop here, and it will break out depending on a particular condition using if statement. Now first, temp is pointing to tree. Now I will check here if the number is less than the temp data. The data is a member of the node type in the structure, as you can see. So if the data, if the num is less than the data, then we have to insert it in the left side of the tree. Now there can be two conditions. We have to go to the left side, and if the left child of this temporary pointer is empty, then we will directly insert the child at that position. But if it is not empty, then we have to traverse, we have to go more towards the left. So I'll first check if temp left is not equals to null. If temp left is not equals to null, which means a child is there in the left side of the temp, so we'll simply traverse it to the left. Temp left, we'll take the temp to the left, we'll go towards the left. Now since the num is smaller, we will go to the left if it is not empty, the left child. But if it is empty, if there is some if there is gap, if it is null, the left child, then we can directly insert to the left of temp. Temp left equals to create node. I can directly create the node here and insert in the temp, and then break out of the loop using the break keyword. So this part. Now in else part, what we will have is num will be greater or equals to temp data. Since in the if part we have num is less than temp data, then in the else part the num must obviously be greater or equals. If it is greater or equal, then this if will not work and else will come in the else. So it will go towards the right, because in this condition num is greater than, or I like to write to the right side when this temp data is less than num, or num is greater than temp data, so it will go towards the right side. So again, like this condition, there can be two cases. Right side, in the right side there may be some child, so we will check if temp right is not equals to null, which means there is some child in the right side, it is not empty, then we'll go towards the right. We'll go towards the right and we'll not break here, because when we go towards the right, the loop will run again. The loop will run again and it will start comparing again if num is less than temp data, like that, because we have to compare one by one after the another, depending on the condition. Now if the right side is empty, then we can directly insert it to the right. Temp right equals to create node num. We can insert it and then break out of it. So this part is the logic for insert, and this is finished. Now what we need is the display function. I will be writing three functions. One is preorder, then inorder, then postorder. These all three functions will be displaying the tree in three types. So let's write first void inorder, preorder first. Here we'll be taking a tree parameter, structure pointer. Then again I need function declaration for inorder, struct node star, then post order, struct node star. Now here I will declare it, define it, void preorder, struct node star tree, let's say, Now this will be a recursive function. This is the logic. You may know this logic. If the tree is null, then we'll simply return from the function. Otherwise, what we will do in preorder, first we print the printf percentage some gap. We print the root element first, so tree data. Then it's a recursive function. Then we print the left subtree. So in the parameter I'll send tree left. Then preorder. Sorry, the spelling is wrong. Order tree right. So first we print the root element, then the left and the right. This is the preorder function, and rest are similar, so we can copy and paste it. It is in order. After preorder we have in order. In order, the root element is printed after the left subtree is printed. In order, left subtree we print first, then the data, then the right subtree in order. Then after this we have post order. Post order. In post order, first we print the left subtree in post order. First we print the left subtree in post order. Then we print the right subtree in post order. And then at last we print the data. We print the root node. So these are the three functions. And now one more function I want to write called void display, where I will call all these three functions, this preorder, inorder and postorder. These three functions I will call inside display, so that only just by calling display from main I can call all these three functions at once. So in display I'll take the tree struct node star. Whether you give star here or after a gap, there is no difference. So we have to define this function here, down, void display struct node star tree. Here I will write printf the tree is \n for better formatting. Printf preorder. Let me not give this gap. Okay, let it be preorder travel cell. Here we'll print preorder. We'll call the function tree. Then printf in order traversal \n for formatting. In order tree. Then printf the last thing, which is post order. Post order traversal. This should be done. After this, let me give some gap. So the tree is in this way will print. Now all the functions are written. One is create node for creating the node. One is insert for inserting the elements. The logic we have already discussed. You can go back and check the video in the previous time by going back in previous time. Then preorder, inorder, postorder, these three functions for displaying the tree in specific order, and then display function which calls all these three functions. Now what is left to be done is completing the main function. Now here we'll take a list of inputs from the user, and for that we need variable size, how many inputs user wants to enter, then the num, which will be repeatedly reading one by one, and then I for running the for loop. So printf enter the size of binary tree. Here I have to scanf %d ampersand size. Sorry for that. Then printf will give a prompt to enter the elements. Let's give a \n here for gap. Now in for loop, we'll read those elements one by one. I less than size, I plus plus. We can scanf %d ampersand num in the num variable, and then we'll just call the insert function, and we'll send the parameter tree. Since we have taken double pointer, we'll send the address of the tree, this tree pointer, comma, then the num. After doing this, we just have to do is call the display function. In display, we'll just send a tree parameter, and this should do it. So let's try whether it runs or not. Let's go to the terminal, minimize this. I'm already in desktop, and the file name is binary3.c. So I will write first. Let me increase the length. gcc binary3.c. Okay, it compiled without errors. Then ./a.out for running. Enter the size of the binary tree. I will say 6. Then let me just give random elements without any thought. 11, 9, one more is required, 10. Okay, the tree is pre-order traversal. This one 4 to 6, 11, 9. This is the pre-order traversal. 4 is the root element here. This is the first element. And in order, this is the 4. In order, what we can see is in the left side and right side, we can clearly see the subtrees. This is the right subtree and this is the left subtree, because the root element is in the middle, and in post order the root element is at the last. And in order, it's in ascending order. In this way we can print ascending order also using in order. And pre-order traversal, we can use this traversal for postfix notations, prefix notations. And in post order traversal, we can use this for printing postfix notation if you have some expression in binary tree. So that's it for this video, guys. Thank you very much for watching this, and sorry for the mistakes if I did any mistake in the concepts in this video. Hope you liked it.